Hi. So this video will be about the Muirhead inequality, and this is very powerful. And some of the viewers have requested this, so I'm going to make a short video explaining how it works and what are the different applications in which you can apply Muirhead. So let's see. Uh, the first idea here that you need to understand is majorization. So what is this majorization of sequences? So let's take an example. If there is a non-increasing sequence, if there are two non-increasing sequences, what is a non-increasing sequence? It is a sequence where the terms are such that either they are decreasing or they could be equal, right? So you order the terms with highest first, and then sequences, the next term will be smaller or equal to the previous term. So that is a non-increasing sequence. If there are two non-increasing sequences like this, A1, A2, AN, and B1, B2, Bn, which satisfy these properties, which satisfy the properties uh, A1 plus A2 plus AN is equal to B1 plus B2 plus B3 till Bn, and summation of I goes from 1 to I goes from k to n, AI is less than equal to summation of I goes from k to n bi. Uh, wait, I have stated this one, so I'll just write it again. We have summation of I goes from 1 to k ai is greater than equal to summation of I goes from 1 to k bi for k less than n, right? And this equality sign is not there. Then the sequence AI majorizes sequence BI. So we write that as sequence AI is, this is the symbol for majorization, sequence BI. We'll take some examples and we'll try to understand what this means. So right now it feels a little abstract. So I'll take some examples. So for example, like if we have a sequence of two numbers, like 5, 1, this is a sequence 5, 1, and the other sequence is 4, 2, right? Now you can see that it satisfies the condition 5 plus 1 is equal to 4 plus 2, right? And it also satisfies the condition 5 is greater than 4, right? So if you take all the terms, sum of all the terms, they should be equal. And if you take sum of first one term or first second term or third term, first three terms, then one sequence sum is greater than the other sequence sum. Then we can say that if this sequence is called AI and this sequence is called BI, then AI sequence majorizes BI. So the first thing to notice here is these are all non-decreasing sequences. So non-increasing sequences. This is one sequence, let's say AI, and there is another sequence 5, 4, 2, right? This is BI. So you can see that these are non-increasing. The first term is the largest term, and then terms following that are smaller and smaller, right? So once we have that condition in place, we have to check the total sum of all the terms. There are three terms here. So summation of AI from I goes from 1 to 3 should be equal to summation of BI, I goes from 1 to 3. That is the first condition. You can check that by saying 7 plus 3 plus 1 is equal to 11, and 5 plus 4 plus 2 is also 11, right? So the first condition of majorization is true here. Now you have to check whether if you sum from I goes from 1 to 2 AI, is it greater than I goes from 1 to 2 BI? There are three terms in the sequence. The total sum should be the same. And any number of terms, if you add, starting from the first term till less than n, if you add, say, less than 3, you add two terms. then the sum of the first sequence should be greater than the second sequence. So here what you will see is 7 plus 3 is greater than 5 plus 4, and also first term 7 is also greater than 5. So if you take the first term only, it is still greater, first sequence is bigger. If you take the first two terms, the second first sequence is still bigger. And if you take all three terms, then the first sequence and the second sequence sum are the same. So then we can say that this sequence majorizes this sequence 542. 731 majorizes 542, right? Sorry. So if you understand majorization, then we can take some examples and figure out what is Muirhead. So this inequality states, Muirhead's inequality states that if sequence A majorizes a sequence B, majorizes a sequence B, right? Then given a set of positive reals, positive reals x1, x2 till xn, we always have the symmetric sum x1 to the power a1, x2 to the power a2, and so on, xn to the power an is greater than or equal to the sequence, the symmetric sum of x1 to the power b1, x1, x2 to the power b2, and xn to the power bn. So what do we mean by a symmetric sum? The symmetric sum is basically take all possible combinations. So there will be, if there are n terms, there will be n factorial terms in this symmetric sum. So if there are three variables, you should have six terms in the symmetric sum. And if there are two variables, you will have only two terms, right? So we will understand this by examples. So what we can say is that this symmetric sum is greater than this symmetric sum because A1, A2, AN sequence majorizes B1, B2, Bn sequence. We'll not do the proof of this, but we'll do some examples. So for example, we have already seen 5, 1 is majorizing 4, 2, right? Because 5 is greater than 4 and 5 plus 1 is equal to 4 plus 2, right? Therefore, we can say that symmetric sum of x power 5 y power 1 will majorize or will be greater than equal to the symmetric sum of x power 4 y square. So that just means that x power 5 y plus x y power 5 is greater than equal to x power 4 y square plus x square y power 4. Because there are only two variables here, x and y, the symmetric sum has only two terms. Okay. So let's take another example. An example of a symmetric sum could be like this. If there are three terms, so symmetric sum of x, y cube, z square will be written like this. You'll write x, y cube, z square plus x, y square, z cube plus x square y cube z plus x square y z cube plus x cube y square z plus x cube y z square. These are the six terms that will come in the symmetric sum of this, right? Now, if the powers are equal, like some powers are equal here, all the powers were different. If some powers are equal, you will get repeated terms also, right? So this is how you write a symmetric sum. You take all possible combination of powers for x, y, and z, right? So let's do some applications, some examples by which we'll learn to apply Muirhead. So the first question is simple. Find the minimum value. Find the minimum value of a plus b, b plus c, c plus a by a, b, c. Now, obviously, we can do it by AMGM, and that is a general rule that anything that you do with Muirhead or Schur's inequality, all of it can be done by AMGM as well. But sometimes AMGM is hard to do because you have to figure out a lot of the terms, and Muirhead is very straightforward to do. That's why we use Muirhead inequality in Olympiad questions. So what we can do is if we multiply this numerator, right? If you multiply this numerator, you will get something like this. 2abc plus a square b plus c plus b square c plus a plus c square a plus b. Now divided by ABC. Now this you can check yourself. This is what will come, and you can say that this second part here, this part here, right? The second part is like 2ABC plus symmetric sum of x a square b power 1 c power 0. This is a symmetric sum like this, because a square b power 1 c power 0 is one term, then another term will be a square c power 1 and b power 0. So a square c. So notice that a square c comes here, right? A square b, a square c comes here. Similarly, b square c, b square a will come. So this divided by ABC, right? So we have the symmetric sum M210. Here I'm writing just the coefficients A1, A2, A3. So here the powers are 2, 1, and 0, right? So this is a symbol that helps us write the symmetric sum instead of writing the summation sign always. So M210 we know will be greater than equal to M110. Why? Why will it be greater than M110? Because 210 sequence majorizes 110 sequence. Why? Not 110 actually, because it has to add up to the same thing. So it will be here 111. 2 plus 1 is 3, and 1 plus 1 plus 1 is also 3, right? So 210 sequence majorizes this because 2 is greater than 1, 2 plus 1 is greater than 1 plus 1, and 2 plus 1 plus 0 is equal to 1 plus 1 plus 1, right? So therefore, we can say that summation a square b power 1 c power 0 will always be greater than equal to summation a power 1 b power 1 c power 1. And we know that there are three variables, so there will be six terms here, 3 factorial or six terms. So therefore, we know that this thing, this symmetric sum is greater than equal to 6 times ABC, right? And if this thing is greater than 6 ABC, you get 2 ABC plus 6 ABC by ABC. So the whole thing is greater than equal to 8. And the same answer would have come if I had done A and GM. I would have done 2 root AB, 2 root BC, 2 root CA, and I would have gotten 8 ABC by ABC, right? So this is how you apply Muirhead. You try to find a sequence which majorizes another sequence, and then express the expression that you want to prove in terms of the majorized sequences. So another example that we'll look at is this one. If x is equal to a plus b plus c, and y is equal to a cube by bc plus b cube by ca plus c cube by ab, right? If a and b, if abc are positive, abc are positive, then which is bigger? Which is bigger, x or y? X or y, right? So we assume let y is greater than equal to x, right? Then if we multiply up and down by ABC, that will preserve the inequality greater than equal to ABC into x. So you'll get ABC into a cube by BC plus b cube by CA plus c cube by AB is greater than equal to ABC into a plus b plus c. So this, if you assume y is greater than x, then this has to be true. And this becomes a power 4 plus b power 4 plus c power 4 is greater than equal to a square bc plus ab square c plus ac abc square, right? Now this thing can be written as a symmetric sum of 4, 0, 0, right? A power 4, b power 0, c power 0, symmetric, and we have to show that that is greater than equal to the symmetric sum of a square b power 1 c power 1, right? Correct. Now now notice that 400 sequence majorizes the sequence 211 because 4 is greater than 2, 4 plus 0 is greater than 2 plus 1, and 4 plus 0 plus 0 is equal to 2 plus 1 plus 1. These are the conditions for majorization. So therefore, this inequality is always going to be true by Muirhead. And what we have gotten here is y greater than equal to x implies this inequality. So therefore, the truth is that y is greater than equal to x. That is the correct assumption because we got that by Muirhead. You can just reverse the steps of all of this, right? Again, one more question that we can look at is uh, find the values of k, find the smallest value of k, smallest value of k such that such that x power 6 plus 5 x power y x power 5y plus 10 x 4 y square plus k x cube y cube plus 10 x x square y 4 plus 5 x y power 5 plus y power 6 is always greater than equal to 0. So we have to find the value of k so that this is always true for all non-negative reals x and y, right? So what I will do is I will write it like this: x power 6 plus y power 6 plus 5 x power 5y plus x y power 5 plus 10 x square y 4 plus x 4 y square is greater than equal to minus k x cube y cube, and I have to find the value of k here, right? Now look at this sequence. This sequence is a symmetric sum of x power 6 y power 0. This sequence is 5 times the symmetric sum of x power 5 y power 1, and this is 10 times the symmetric sum of x square y power 4, right? Or x power 4 y square. Let's write it like that, right? So the sequences here are 6 0 and 5 1 and 4 2, and you will notice that all of these sequences majorize the sequence 3 3, because notice that 6 plus 0 is equal to 3 plus 3 and 6 is greater than 3. 5 plus 1 is equal to 3 plus 3 and 5 is greater than 3, and 4 plus 2 is also greater than is equal to 3 plus 3 and 4 is greater than 3. So since the sequences majorize this, we know that all of these symmetric sums are greater than the symmetric sum of x cube y cube, right? Okay, so then we just count it, right? So here we have, this is greater than, there are how many terms in this sequence, symmetric sequence? There are two terms, right? So this symmetric sequence will just be 2x cube y cube. So each of these sequences is greater than 2x cube y cube, each of these summations. So this is greater than 2x cube y cube. This is greater than 5 into 2, 10x cube y cube. And this is greater than 10 into 2, 20x cube y cube. So the whole LHS is greater than equal to 32 x cube y cube. So k can be minus 32. K has to be minus 32, right? Are you understanding what we are doing here? Like, we are basically trying to see if we can construct sequences which majorize each other, and then we can say that the symmetric sum is greater than the symmetric sum with the minorized sequence, right? One more example we'll do before we end this video. This example gives a special case where the inequality is not homogeneous. So x, y, z are positive real numbers, positive reals. Now suppose x, y, z product is equal to 1, and we have to show that x power 10 plus y power 10 plus z power 10 is greater than equal to x power 9 plus y power 9 plus z power 9, right? Now the problem here is that the left hand side and the right hand side terms don't have the same degree. On the left hand side you have degree 10, on the right hand side you have degree 9, right? So if they don't have same degree, then they are not homogeneous and you cannot use Muirhead directly. So you'll have to do some minor modifications to get it into a symmetric shape. So what we can do is we can multiply something here, something like xyz, right? Xyz, if I multiply, each term here will have degree 12. So I want to multiply in such a way that it becomes degree 10. So I should multiply by xyz to the power 1 by 3. Why? Because if I multiply each term like this, xyz to the power 1 by 3 into x power 9 plus y power 9 plus z power 9, then you will realize that this becomes x power 9 plus 1 by 3, or 28 by 3, y power 1 by 3 and z power 1 by 3, plus x power 1 by 3 x power, not y power 1 by 3. This is 9, correct. X power 1 by 3, y power 28 by 3, and z power 1 by 3, plus x power 1 by 3, y power 1 by 3, and z power 28 by 3. What is special by about doing this multiplication? Because this is 1, this is also equal to 1, so this doesn't change the value of the RHS. What it does, it changes the degree of the terms. Each term has now degree 10, because 28 by 3 plus 1 by 3 plus 1 by 3 is equal to 10, right? 30 by 3. So now we have to prove just this: x power 10 plus y power 10 plus z power 10 is greater than equal to the symmetric sum of x power 28 by 3, y power 1 by 3, and z power 1 by 3. Now, this is the symmetric sum of x power 10, y power 0, and z power 0, right? Is greater than equal to this symmetric sum: x power 28 by 3, y power 1 by 3, and z power 1 by 3. Now, because 10 0 0 is a sequence here, the sequence here is 28 by 3, 1 by 3, 1 by 3, you can easily see that this sequence majorizes this. Why? Because the sum of all three terms is equal. First term here is bigger than this, and first two terms combined is also bigger than this. So this sequence majorizes it. So then that by Muirhead proves that this symmetric sum should be greater than this. And you can now reverse the steps. You can start off by saying this sequence majorizes this sequence, write this symmetric sum inequality by Muirhead. Then you take x, y, z to the power 1 by 3 common. And since that is equal to 1, you can show that now x power 10 plus y power 10 plus z power 10 is greater than x power 9 plus y power 9 plus z power 9. So this is how you apply this Muirhead inequality. The standard strategy in Olympiad problems is, if you have fractional expressions and homogeneous expressions on left and right hand side, what you should do is clear out the denominators, multiply out everything, and then the expressions that you get, try to write them as symmetric sums. Symmetric sums involving certain sequences. And if you can prove that the sequences themselves are being majorized by another sequence, then you can replace them with another different symmetric sum, which is probably what will be needed to solve the problem. As we go along in the course and we do multiple problems, we will see examples of this, and we'll see it through applications that will help us appreciate the power of this particular theorem. Uh, as an aside, what you guys should try out is IMO problem 1995. IMO 1995, there was an inequality based on Muirhead, which all of you can attempt right now. Basically, the question is this. I will leave it for you guys to figure out. For ABC greater than 0 and ABC is equal to 1, prove that 1 by A cube B plus C plus 1 by B cube C plus A plus 1 by C cube A plus B is greater than equal to 3 by 2. This is IMO 1995. And the proof is by Muirhead only. What you have to do, I will outline the basic strategy. Just take the common denominator, multiply out everything, take the denominator on this side. So you'll get LHS and RHS in terms of symmetric expressions of A, B, and C. You will write all of those in terms of symmetric summations. And eventually you will have to think of which sequence majorizes which sequence and replace it using Muirhead. So try this out as a homework. If you can do this question, you are well on the way to understanding this inequality and using it in Olympiad problems, right? If not, just let me know. We'll do a solution of that in the future. See you next time. I hope this video helped.